Now coming to the electrodes. As I said you already, we are having two electrodes. One is your cathode, another is your anode. Cathode is negatively charged, anode is positively charged. Isn't it? Now we will understand what it happens during an electrolytic reaction. Let me write an electrolytic reaction and explain you that what it happens at cathode and anode. Okay. Let us take here fused sodium chloride. Fused or molten sodium chloride. It dissociates to give you Na plus Cl minus. See, this is your cation and this is your anion. Cation is positively charged and anion is negatively charged. Okay. Now, this is your electrolyte, a strong electrolyte. Remember it. Strong electrolyte is your sodium chloride is a strong electrolyte. Got it? Strong electrolytes are all dilute acids, all dilute mineral acids. They are considered to be a strong electrolyte. Dilute HCl, dilute H2SO4, dilute HNO3. They are strong electrolyte. Even HBr, HI, they are considered to be strong electrolyte. Sodium hydroxide, potassium hydroxide, they are considered to be a strong electrolyte in case of bases. In case of salt, sodium chloride, sodium sulfate, potassium chloride, potassium nitrate, then lead nitrate, lead bromide, they are all considered to be as strong electrolyte, either in the aqueous state or should be in the molten state. Mind it, always it should be in aqueous or molten state. Alright, or aqueous state or molten state. I'll say you why, don't worry. Now next is weak electrolytes. I already said you that some molecules will be there, ions will not be there. There will be equilibrium between molecules and ions will be there. Got it? In case of weak electrolyte, an equilibrium between molecules and ions will be there. In non-electrolyte, only molecules will be there. Achha. So if you ask me the examples of weak electrolyte, already I have discussed with you. So ammonium hydroxide is a weak electrolyte. Apart from that, you are having, in case of acid, you are having acetic acid, vinegar, oxalic acid, formic acid, carbonic acid. They are considered to be as weak electrolyte. Similarly, in bases, if you say me, then it is your calcium hydroxide. Then magnesium hydroxide, calcium hydroxide, it's lime water, we can say that. Magnesium hydroxide, then ammonium hydroxide, they are considered to be as weak bases. And in case of salts, we can say that sodium carbonate, sodium bicarbonate, potassium carbonate, potassium bicarbonate, alright, they are considered to be as weak electrolyte, we can say that. Alright, so all these which I named you as weak electrolyte, again I repeat, they dissociate feebly. They do not dissociate completely, they dissociate feebly into its ions. That means you will be having, that is a mixture of molecules and ions. That is, molecules and ions will coexist in case of weak electrolyte in solution, we can say that, or in the molten state, whichever you are taking it. Now, electrodes, I was talking to you, we are having two electrodes, that is anode and cathode. Got it? So here you can see this is your cations and this is your anions. Already I said you, cations are positively charged ions. They are basically metallic ions or hydrogen ions. And anions are negatively charged ions. They are basically non-metallic ions. Non-metallic ions, or what you can say, negatively charged radicals like sulfate, OH minus, they are said to be as. Okay? Clear? You must remember it. Now, see, when I do the electrolysis at cathode, what will happen? Which will go to the cathode? Definitely cations will go to the cathode. Very easy to remember, Cc and AA. Cations, cathode. So, cathode is negative, so cations has to be positive. Oppositely charged. Because always remember, oppositely charged attracts. Like charges repels, unlike charges attracts. So, it's easy to remember. So, this is cations, it will go to cathode because cathode is negatively charged. This is anions, we can say that, which is negatively charged, it will go to what? Anode, because anode is positive. Very easy. Cc, cations, cathode. Anions, anode. Okay? Now at cathode, Na plus E minus will give you what? Na. Because Na plus means what? Deficiency of electrons it is having. So it is gaining an electron to form Na. So in cathode what happens is that reduction takes place. Because you have studied in lower classes that a gain of electrons is otherwise known as reduction. So always remember that at cathode always reduction takes place at cathode. Always reduction takes place. Because cathode cations goes and cations will always gain electrons. Got it? So in this way, so we are getting a reduction reaction takes place at cathode. Now at anode, what it happens? At anode, that is Cl minus E minus will give you Cl. So Cl minus means an excess of electron is there. So it is going to lose that electron to form neutral Cl atom. Now how it is forming neutral? See, it is here. Look here. Minus into minus is what? Plus. This is plus and this is minus. Plus minus is it neutral? So hence you get a neutral atom. Now here how it is Na plus changes into NaCl. Plus into minus it is minus. So minus and plus. What is that? Again neutral. 0. Understood? Simple maths it is. Minus into minus is plus. Plus and here it is minus. Alright. It is plus minus what? 0. Cancel. Here also same thing. Plus into minus is minus. And here it is plus. Minus plus again it is 0. Neutral. So here it is what? It is oxidation. So remember that oxidation always takes place at anode. Loss of electrons is oxidation. So oxidation always takes place at anode. Got it? Now Cl is neutral atom. Now Cl does not exist in the atomic state. You know that. Cl is a diatomic gas. It's a diatomic molecule. So it exists in the molecular state. So Cl plus Cl will give you Cl2, which will be liberated as a gas. So when you will carry out the electrolysis of sodium chloride, molten sodium chloride, what is the observation you see? You will say, listen carefully, you will say that greenish yellow gas is liberated from anode because chlorine. Because observation means what you see. Don't say sodium is collected at cathode. How will you know? How will you know sodium is collected at cathode? Can you see? No, you can't. Then why you are saying that? Don't say. So hence what you will say at anode, you will say that a greenish yellow gas is liberated from anode because you can see that gas. Can you see sodium there? It's collected? You can't. Theoretically you know that. Practically can you see? No. So whatever you are seeing, that is your observation. So observation is a greenish yellow gas is liberated from anode. Got it? That is your chlorine. So hence what you find is that at cathode cations goes, at anode anions goes. And in this way it converted into neutral atom which combines with another neutral atom to form a molecule. So what you find is that oxidation reduction takes place at cathode reduction and anode oxidation. So an electrolytic reaction is also called as a redox reaction. You know what's the redox reaction? You have studied in lower classes, where oxidation reduction takes place together. Oxidation reduction takes place together. That is called as a redox reaction. So an electrolytic reaction is also known as a redox reaction. You can see in front of you it is the redox reaction. Here it is gain of electrons, it is reduction. Alright, so always in cathode the gain of electrons is going to take place. So always in cathode reduction is going to take place. Alright, and anode oxidation takes place. Alright, so if you say the differences, this is one of the difference between cathode and anode. That in cathode reduction takes place, anode oxidation takes place. In cathode gain of electrons takes place and anode loss of electron takes place. Alright, always what you find is that suppose let us say this is an electrolytic vessel, a small one I am making it. Alright, this is connected to a battery. You see it here, it is connected to a battery. This is negative, this is positive, this is positive, this is negative. Now this is your anode, the positive terminal, and this is negative terminal is your cathode. Got it? You know it? Now see here, what it happens here, this is an electrolyte. So what it happens here? So current always flows, sorry this is positive. Now current always flows from positive to the negative terminal of the battery. So current flows in this direction. This current is noted with letter I, you know that. You have studied in physics. Current is not letter I. The current is flowing from the positive to the negative terminal. Got it? So what you can say is that always current enters the electrolyte through anode. Listen carefully. Always current enters the electrolyte through anode and always a current leaves through cathode. Current leaves through cathode. It is leaving through cathode, but it is entering through anode. Got it? Anode is the positive terminal because it is connected to positive terminal of the battery, and cathode is the negative terminal. It is connected to negative terminal of the battery. We can say that. Clear? You got the reactions. You came to know also where oxidation takes place, reduction takes place. It's also called as a redox reaction. That also I said you. Now next is ions. I said you already that cations are positively charged, anions are negatively charged. I said you. That is what you find is that in cations they gain electrons and anions they lose electrons to convert it into the neutral atom. Alright, so this is very simple. Cations migrate towards the cathode and anions migrate towards the anode. Already you know it about this particular thing. So now next is after that, so you understood cathode, anode and all these things. Now next is about the electrode. Let me tell you one more thing, that electrodes basically are of two types. We are having inert electrode and active electrode. Inert electrode and active electrode. What I said you? Inert. Inert electrode means which do not participate in the electrolytic reaction. Does not. For that reason it's called as inert. That means when you dip the inert electrode in an electrolyte, it has got no reactions with it. No reactions. It does not participate in the electrolytic reaction. So which are those? Iron electrode. Then graphite electrode. We can say graphite. Let me write graphite. Graphite electrode, which is also denoted with letter C, carbon. We are also having gas carbon electrode. Gas carbon means carbon electrode It's not that a carbon electrode having gases in it. No, that the name is a gas carbon. One of the allotropes of carbon is called as a gas carbon. Okay, one of the allotropes, mind it, allotropes of carbon is called as gas carbon electrode. In this way, we are having iron, graphite, gas carbon. We are having platinum electrode, which is also an inert electrode. We can say that. So these are the inert electrode. It does not participate in the electrolytic reactions. Now, active electrode. All metal electrodes are active electrodes except iron and platinum. Except iron and platinum, all metal electrodes are active electrodes. They participate in the electrolytic reaction. How they participate, I will tell you. I will tell you how they participate and how they do not participate. I will tell you. But now for the timing, remember it that inert electrodes are this. We can say it can be iron, graphite, gas carbon, or simply carbon. We can say that carbon electrodes and platinum. And active electrodes, what I wrote it here, sorry. Active electrodes is your nothing but is your metal electrodes are active electrode except iron and platinum. We can say that. Now, next is we need to understand two words. One is your ionization, another is your dissociation. Ionization means what happens is that ionization is a word, it is used for the substance which are covalent in nature. But when you dissolve in water, it becomes electrolyte. Ionization means the ions are not present in the electrolyte. Ions are being produced on dissolving in water. Now let me make it more clear. Like HCl, you know, hydrogen chloride, it is a covalent compound, you know it. It's a gas, it is a non-electrolyte. When you pass it through water, got it? It becomes aqueous. When you pass hydrogen chloride through water, it becomes aqueous or dilute HCl. Now this is an electrolyte. Got it? So HCl, what you will say? You will not say HCl dissociates into its ions. HCl ionizes into H plus and Cl minus. Because in case of HCl, ions are not present. Remember it, ions are not present in case of HCl. When you dissolve in water, then the ions are being produced. So this process are called as ionization. So ionization is a term used for covalent compound. It's a term used for covalent compound. For example, acetic acid, CH3COH. It is also a covalent compound. It does not contain ions, it contains molecules. You know that covalent compound contains molecules. So if you take aqueous, same thing, aqueous, acetic acid or vinegar, you know that. It does not, don't say dissociates into its ions, it ionizes. So CH3CO minus plus H plus. Alright. If you say, so still I am using it, this particular one, wrongly you are using it. Wrongly you are using it. So you learn it that the ionization is a term which is used for covalent compound. Covalent compound ionizes. But which covalent compound? The covalent compound which is soluble in water. That is polar covalent compound. You have studied in what you can say bonding chapter. There is a polar covalent compound. HCl is a polar covalent compound. CH3COH is a polar covalent compound. They are soluble in water. So they ionizes. They undergo ionization. So we use the word ionization. But in case of NaCl, we use the word dissociation. So for ionic compound or electrolyte compound, we use the word that is nothing but ionization. We use the word ionization. Why? Dissociation, we use the word. For ionic compound, we use the word dissociation. For covalent compound, we use the word ionization. Now, why we use the word here dissociation? Because in case of ionic compound, ions are present. You know sodium chloride is an ionic compound. It is made up of cations and anions. Sodium ions and chloride ions. The ions are present. Got it? Ions are present there. Got it? It's made up of ions only. Sodium chloride is made up of ions, cations and anions. Sodium ions and chloride ions, they combine to form, that is sodium chloride. How they combine? They undergo electrostatic force of attraction. Between sodium ions and chloride ions, there is electrostatic force of attraction. So when you are heating it, this electrostatic force of attraction decreases. When you are heating it, the electrostatic force of attraction decreases to such an extent that it dissociates into its ions. What I said you? It dissociates into its ions. So hence I use the word dissociation. So for that reason, remember it, solid sodium chloride does not conduct electricity. Just now I was saying, you know, that why electrolytes should be in the aqueous solution state or should be in the molten state. Understood now? Because in case of solid sodium chloride, in case of solid electrolyte, like sodium chloride, ions are present. Don't say ions are not present. Ions are present, but the ions are not free. Ions are not free. Due to the absence of free ions, it does not conduct electricity. But when you heat it, when you dissolve in water, what happens? Listen carefully. When you are heating it, the electrostatic force of attraction decreases. When you are heating it, the kinetic energy increases. You have studied all this in kinetic molecular theory of matter. When you are heating it, the electrostatic force of attraction between the sodium ions and the chloride ions, it decreases because the kinetic energy increases. And this helps to dissociate sodium chloride into its ions. That is sodium ions and chloride ions. Got it? Similarly, when you dissolve sodium chloride in water, what it happens? It also, sodium chloride when you dissolve in water, NaCl aqueous. It dissociates to give you what? Same thing, Na plus Cl minus. Aqueous means that is nothing but water. I said you just now to you, water will dissociate to give you H plus and OH minus. So exactly what it happens, listen carefully. Now water has got a high dielectric constant. You will be reading dielectric constant in physics. Now water is only liquid, remember it, which has got a very high dielectric constant. Now dielectric constant, what it does? It helps sodium chloride to dissociate into its ions. It helps sodium chloride to dissociate into its ions. How? Because H plus ions pull the Cl minus ions towards itself, and OH minus ions pulls the Na plus ions towards itself, due to which sodium chloride dissociates into its ions, and hence sodium chloride, due to the availability of ions, which sodium chloride? Aqueous sodium chloride, due to the availability of ions, it conducts electricity. But in the again solid state, let me repeat, in the solid state the ions are present. Don't say the ions are absent. No, the ions are present in the solid state, but the ions are not free. Due to the absence of free ions, so solid sodium chloride does not conduct electricity. But in the aqueous solution state, in the molten state, these ions are set free because they dissociate. Here it dissociates. Here it dissociates, you can see that. Here also dissociates. How it dissociates? I said you, because water helps to dissociate, because water has got a high dielectric constant. Got it? Due to the high dielectric constant, it pulls the oppositely charged ions towards itself, and due to which it dissociates into its ions and helps it conduct electricity. So understood now? The dissociation is a term used for ionic compound, and ionization is a term used for covalent compound. So use it correctly. You also came to know that why electrolytes are not solid. Got it? Electrolytes are never solid, because in solid state the ions are not free. Remember it. For that reason electrolytes are always in the molten state or in the aqueous solution state. Always. Because in the molten or aqueous solution state the ions are free. And always remember that in case of electrolysis, in case of electrolytes, ions are responsible for the conduction of electricity. Ions are responsible, and due to the presence of ions only it conducts electricity. If the ions are not present, it will not conduct electricity. Thank you.